For more complex logic, sometimes control flow graphing that usually represents the lines of code as in a format of visual representation is used. The one that is presented here is the Etzel notation, and it basically shows nodes, edges, and regions. So you can take a look at the nodes. Nodes can be connected by the edges, and there are at least one region inside the nodes, and we can also consider an outside region. This Etzel notation can be used to show the basic structures of programming. Every programming language has definitely some type of these basic structures or constructs. So if we take a look at the first example, we have a do while, and I will guide you to this one also, that is a do until, because basically these are repetition structures. You actually they iterate over a block of code. So the main difference between these two structures is where the decision is. So in this first example, the decision is, and the condition that should be assessed is at the beginning of the repetition block. In here, the decision that has impact on the iterations of the block of code that gets repeated is done at the bottom of the code block. Okay, so this is a basic example where you can actually see that if the decision is assessed up to true, you execute the code and then you return once again for the decision. Once the decision gets assessed as false, you leave the iteration and you move on to the next lines of code. In here, the decision will only be conducted after the first time that the block of code is executed. Taking a look at another structure, we can actually see that an if then else is represented by two nodes that are connected with two edges. Okay, one corresponds to the yes, the other corresponds to the no. One is the path that is followed if the condition is assessed as true. The other one is the path that is followed if the condition is assessed as false. Another important structure is the goto structure, where you have a non-conditional loop, and you establish a jump in your lines of code, and you establish that somewhere in your program you jump up to another line instead of continuing the process of sequential programming. Basically, this notation is highly recommended for graphs, but it only shows the logic flow. So if we consider this example once again, and we try to represent it as using the Etzel notation, we will get to this example. This does not show us where the executable statements are, and it's quite simple, and it's not very useful because from line 1 you get to line 3 whether the condition is assessed as true or yes, or as false or no. You don't actually get enough information from this notation. So a slight modification of the notation can introduce an extra node that is related to line number 2. So if we take a look at the visual output of this modification, we get line 1, line 2, and line 3. And this is the path to follow from 1 to 3, and ensuring that the statement that is present in line 2 is executed, and the other branch is here available, okay? And for achieving the 100% statement coverage, you don't have to go through both branches, okay? You only have to go to this branch, and actually you can ensure that the statement is executed. This sums up the basic knowledge and the basic idea for statement coverage. Okay, let's take another example. In here, we have an if that has an executable statement in line number 2, and then an else that is executed when the condition is assessed as false, okay? And line number 4 has another statement. So in here we have 2 statements, and if we represent this visually, we get this type of diagram that shows us that from line 1 up to line 5, I can go following 2 distinct paths. The first path ensures that the statement number 2 is executed. In the second path, it ensures that the statement number 4 is executed. So we will need 2 tests to achieve 100% statement coverage. Regarding this example, we have 9 lines of code. We have 3 statements. The statement that is present in line number 3, the other in line number 5, and the last one in line number 8. So if we consider to present the diagram visually, okay, we can see that from line 1 up to line 9, we have at least 3 options for paths. And in order to address that line number 3, line number 5, and line number 8 are all executed, I have to define or design at least 3 test cases. So for instance, test case number 1 could be this one, test case number 2 could be this arrow, and the last test case could be represented by this last arrow here at the right. If we try to design a test case, for instance, test case number 1, we can actually say that the fuel tank is empty. That will lead us to this yes branch. Then we can say that we have a petrol engine, and then we are guided to this yes branch of line number 2, okay? And then the statement number 3 gets executed. Then we end the decision, and then we end the first decision. Regarding test case number 2, we can say that the conditions for the test case are the following. The fuel tank is empty. So I get to the line of code number 2. The engine is not petrol. Okay, so I'm directed to this other branch of the decision, and I get to line number 5. And in line number 5, I execute the statement, and then I complete the 2 decisions. Regarding test case number 3, one good example for the design of this case and the test case conditions is that the fuel tank is not empty. So if the fuel tank is not empty, I carry on driving, and then I get to the end of the code. So basically we will need 3 tests to achieve 100% statement coverage. Finally this, I have 4 statements. Line number 2, line number 4, line number 7, line number 9. If I represent them visually, I get a diagram similar to this one. If you take a close look at what happens, you can actually see that starting from line 1 and ending at line 10, you get to achieve through all the statements if you only define and design 2 test cases, because each test case will address 2 executable statements. Okay, so for instance, in test case number 1, the one on the left, we can be coffee drinkers that want cream on their coffee. And regarding test case number 2, we are not coffee drinkers, so we get served tea, and we don't want cream, so we get served milk. Okay, so this is what is needed to achieve 100% statement coverage. 2 tests.